Hey guys, welcome back to chapter 4. In the last video, we talked about how to predict ions. And that's going to be really important in this video because we're going to take it to the next level and start putting these compounds together. So let's take a look at an example. So our poster child for ionic compounds is sodium chloride. So looking at sodium chloride, we see that sodium has a +1 charge. So he's in that first group. He's got one valence electron, and he gives that one valence electron away to have a positive charge. Chlorine is in group 17 or 7A. He's got 7 valence electrons. He steals 1 electron, and he gets a -1 charge. So when looking at ionic compounds, we have kind of 2 rules that we're going to keep in mind. Rule number 1, positives attracted to negatives. So that one's pretty easy. Rule number 2, when we have a compound, it must be electrically neutral, meaning that all of the positive charge and all of the negative charge must cancel each other out. So here we see sodium has a +1 charge. Chlorine has a -1 charge. So when they come together, the +1 and the -1 cancel each other out, and we get NaCl. Okay, that's the ionic compound for NaCl. Let's take a look at another example. So what about a compound between magnesium and chlorine? Okay, this one also exists. I'll tell you that right away. So magnesium's in the second energy level, is in the second group. Magnesium has 2 valence electrons, and he's going to give those 2 away. So he's going to have a 2+ charge. Chlorine, again, still in 17, still has 7 valence, still steals 1 electron, so he's going to have a -1. Now, chlorine and magnesium can't just come together as MgCl. The reason for that is this +2 does not cancel out this -1. If I just had 1 magnesium and I had 1 chlorine, that would carry kind of all together still a +1 charge. And that breaks one of our rules. It has to be electrically neutral. So what we need in this case is we're going to need 2 of these chlorine atoms or ions to balance out that +2 charge on magnesium. So when we write the chemical formula for magnesium and chlorine, we write MgCl, and then this 2 down here tells us that we've got 2 atoms of chlorine for every 1 of magnesium. So why is that? Why do we need 2? So I'm going to tell you kind of a little silly anecdotal story, but hopefully this will help to drive it in. I'm about to draw valence electrons as dots. So this is something you're going to see a lot more when we get to covalent, but just kind of like watch and follow along. So we've got magnesium here. Magnesium is in the second group, so he's got 2 valence electrons. So I'm going to draw those electrons as little dots right here. So magnesium has those 2 dots. He would like to get rid of those 2 valence electrons. He's trying to give them away. So let's say magnesium's kind of hanging out at a party. He's trying to give his 2 electrons away, and he comes into contact with a chlorine. Chlorine has 7 valence electrons, so 1, 2, 3, 4, 5, 6, 7. So magnesium starts a conversation with chlorine. He's like, hey, I'm really trying to get rid of these valence electrons. Do you want them? Chlorine says, you know what, I actually do need another electron, but I don't want both of them. I just want one of them. Don't give me both. So magnesium's like, better one than none. So he goes ahead and he gives or transfers this electron to chlorine. Transferred. Okay. So now chlorine has his 8 valence electrons. He's happy. He goes off somewhere else. Magnesium's like, wait a minute, I still have this 1 valence electron. I gave 1 to chlorine. Maybe I can find another chlorine and he'll take my other one. So magnesium comes to a different chlorine who brings with him 7 valence electrons. And magnesium has the same conversation with this chlorine. Hey, trying to get rid of this 1 valence electron. Do you think you might want it? Chlorine says, yep, absolutely. I would love to take that off your hands. So there's a transfer. He takes on that electron. And now this chlorine is happy. Magnesium has gotten rid of his 2 valence. And he's happy. And we're all good and well. So this story just to tell you that 1 magnesium has to have a conversation with 2 separate chlorine atoms in order to get rid of both of his electrons. He can't just have a conversation with 1, he must have a conversation with 2. And the way that we symbolically represent that in chemistry is magnesium has a conversation with 2 chlorines. Quite often in chemistry, the number 1 is implied. So there's a number 1 here next to magnesium, saying 1 magnesium talks to 2 chlorines. If it makes sense in your brain to put that 1 for a while, that's fine, no big deal. But eventually we would get rid of that because we typically imply 1s in chemistry. So going back to what we saw before, magnesium with his +2 charge, chlorine with the -1, so we need 2 of those chlorines to balance out that 1 magnesium. So let's take a look at some examples. So here we see 4 formulas. One of them is not electrically neutral. So see if you guys can decide which one is not electrically neutral. Pause the video and give it a try. All right, so looking at A, potassium is a +1. Bromine is a -1, so those balance. That one's good. Magnesium is a 2+. Fluorine is a 1-, so we need 2 fluorines for that 1 magnesium. That one's good. Cesium is a 1+. Nitrogen is a 3-. Here it says we have 1 and 1, but that's not going to work. A +1, a -3, So what would we have to do to fix this? Yeah, we would need 3 cesiums for this 1 nitrogen. So we've got cesium with a 3, and then just 1 nitrogen. Next example here, we've got 4 different chemical names or naming the compounds. I want you guys to see if you can draw the formula for each of these. Let me do the first one with you. So aluminum, the first step is to get the chemical symbol onto the paper, so Al. And chlorine, so chemical symbol for chlorine is Cl. I've given you the table here with the charges, but I really want you guys to start to try to predict the charges. Think of this as training wheels, and eventually we want to take those training wheels off. But for right now, we see aluminum has an ion with a +3 charge. Chlorine is an ion with a -1 charge. So if I were to write this as electrically neutral, I would have 1 aluminum. And then I would need 3 of these chlorines. So AlCl3. Go ahead and pause the video and see if you can work out the other 3. All right, so calcium is in the second group. He has 2 valence electrons. He's going to give those 2 valence electrons away and have a positive charge. Iodine is in the 17th or 7A. He's got 7 valence electrons. He's going to steal 1. So in order for this 2 and this 1 to balance each other out, we would need 1 calcium and 2 iodine. All right, beryllium. Beryllium is where? Where's beryllium? He is not on this table. So we got to get our periodic table out. Beryllium is right here. So beryllium is in the second the second group. He's got 2 valence electrons, and those 2 valence electrons he's going to give away. So he's going to have a 2+. Iodine is still going to be a -1. We just did him in the last example. So to write this formula as electrically neutral, we would need 1 beryllium and 2 iodine. Last one is calcium and sulfur. So calcium is in the second group. He's got 2 valence electrons, and he gives them away. Sulfur is in 16 or 6A. He's got 6 valence electrons, so he's going to steal 2, so 2-. Calcium is a +2. Sulfur is a -2, so they balance each other out. We just need 1 of each. So the chemical formula for that guy would be CaS. So that is predicting ions and then putting them together into an ionic compound. The 2 rules that we have to abide by: number 1, positive is attracted to negative, so one will be positive, one will be negative. Second rule is that they need to be electrically neutral. So the positive charges have to balance out the negative charges, and if we need more than 1 atom to make that happen, that's exactly what we do. I hope you guys found this helpful.